Hello everyone, today's question: are all photochemical reactions generally zero order or not? Okay, so before going to the actual discussion, I would like to mention, please have a look in the description box below where you will find all the important playlist link for different topics. First, we will see what is order of a reaction. So it is the number of reactant entities whose concentration affects the rate of reaction directly. Fine. So here we have reaction A moles of capital A, B moles of capital B reacting with each other. We are getting product P. And the rate law which is found experimentally, that is presented here. Rate is equal to small k, which is rate constant, then concentration of A to the power x, concentration of B to the power y, and this value of x and y together, that will give us the value of order. Okay, now this value which is obtained by summation of this exponent of the concentration terms, which is present in the rate equation or expression, and remember this is found experimentally. This value, it is not necessary that it will be same as the value of this coefficient small a and small b. It may be same, but it is not necessary that it will be same. So if you write the balanced equation, then from that you cannot write rate law. You have to know the rate expression or rate equation which is determined experimentally. So look at the third point. It doesn't depend on the stoichiometric coefficient of the reactant that is present in balanced equation. So that is why this small x and small y, it has nothing to do with this value, that is small a and small b. Now this order, it may be zero, integer or fraction. So when we have any zero order reaction, what it means? Now this value of x and y, it will be 0. Now when these exponent terms are 0, that means rate will be constant. Fine. So for zero order reaction, rate of reaction is constant and it is independent of the concentration of the reacting species, because in this case this value, that is x or y, that is individually it may be that x is 0. In that case you will say it is zero order with respect to A, or it may be that is summation is 0. Okay, so that is overall zero order. So rate of reaction is constant and independent of the concentration of the reacting substance. Now next, photochemical reaction, because we are trying to understand whether for photochemical reaction order is 0 or not. So what is photochemical reaction? As we are using the word photochemical, so obviously now the reaction will take place by absorption of energy in the form of light. So whenever we have any reaction, energy is required. Now this energy can be provided in the form of light, or it may be also in form of, that is thermal energy. Fine. So in this case it is in the form of light. So the consequence of absorption of light is that when the molecule is present in the ground state, now after absorption of energy in the form of light, there will be formation of a transient excited state. So this is transient excited state whose chemical and physical properties completely different from the original molecule. So now the electron is in the excited state and the energy gap between these two states, that is del E. So we know that molecules' energy levels are always quantized. So obviously not just any energy, whether we, that is when we are providing it, it is not necessary that it will be enough. So that amount of energy will be required which is just matching with the value of del E. So the amount of energy required to raise an electron from one level to higher level in a given molecule, that is actually constant, fixed. Fine. So only that light which is having the exact frequency matching with this del E value, only that light will affect the electron to move to the higher energy level. So if we see any example for this type of photochemical reaction, you can consider the reaction of formation, that is from oxygen when O3 is formed. So here what happens in presence of H nu, if we consider diatomic oxygen molecule, there is formation of 2 oxygen atoms, and these oxygen atoms, which is basically the transient species as it is mentioned here, this single oxygen, it can react with, this single oxygen, it can react with O2 and it can form O3 molecule. Okay, So this is example of how any photochemical reaction can take place to the formation of excited state, and for this formation of excited state, absorption of energy in the form of light is necessary. So for thermal reaction, basically this is the energy profile diagram. That is very simple energy profile diagram. Remember, it is always collision based. So it can only occur if collisions are occurring frequently enough. Otherwise this is not possible, because only through collision with enough energy it is possible to overcome this energy barrier, which is basically known as activation energy. So this is for thermal reaction. But when it is photochemical reaction, the case is different. So this is not, first of all, it is not collision based. Fine. So when it is not collision based, it doesn't matter what concentration you have taken for the molecules, because concentration is number of molecules in a particular volume. So if it is not dependent on collision, so obviously concentration is not important. So it involves not collision, but either overcoming the activation barrier with exact wavelength as energy levels are quantized, fine, or not. So either you overcome this energy barrier or not, fine. There is no in-between situation. So rate of photochemical reaction increases when there is increasing intensity of light. That means number of photons when high, then only it is possible. It has nothing to do with collision. So that is the reason now we can say that all photochemical reactions are generally zero order. Because remember, in case of zero order, what we have mentioned? In case of zero order, we have mentioned that rate of reaction is constant and it is independent of the concentration of the reacting substance in this black colored box. Fine. Now if this is the case, now obviously photochemical reactions, as it is not dependent on the concentration of molecules, so they are generally zero order. Okay, so the answer of today's question, whether photochemical reactions are zero order or not, yes, they are generally zero order. Fine. So I hope that you got the answer of today's question. I will meet you in the next video.